Okay, so the first thing to think about here is what atom will be at the center of this ClO4 minus ion. And this is pretty easy to figure out. You always put the atom with the lowest electronegativity at the center. And we can see that chlorine has a lower electronegativity than oxygen just by looking it up. But you should also probably know this. So we're going to have a Cl at the center and 4 oxygens around it like this is how we'll draw this. I won't draw the bonds yet because we don't know how many they're going to be. So let's think about valence electrons for a second. Chlorine has 7 valence electrons. So that's 7. Oxygen has 6 each for a total of 24. And then lastly, we want to add 1 because we've got a 1 minus ion. So that's a total of 32 valence electrons. Okay, so the simplest structure we could draw here would just be a single bond on every ClO. And then 1, 2, 3, 4, 5, 6. I'll just draw like this, but lone pairs around all, 3 lone pairs on each oxygen. Now, this does seem nice because it doesn't violate our octet rule on the chlorine, but let's look at formal charge for a second. So these are 3 lone pairs plus 1 bond. That's going to be 7 for our total number of electrons in this area on each of them. And since oxygen has a 6 valence electrons, this is an extra electron on each one. So all of these have a formal charge of -1. That's not very good. It's 4 different atoms with a formal charge that's not 0. But more importantly, this chlorine only has 4 electrons, whereas it's got 7 valence electrons normally, so it's got a formal charge of +3, which is too big to be acceptable. If you ever see a formal charge of +3 on an atom, on an atom in a molecule, chances are you've got the wrong structure, because that just doesn't really happen. Outside of some ionic compounds, of course. So let's think about this. What if we add some double bonds? Well, if we add 1 double bond, make this 2, this fixes this oxygen. This oxygen now has a formal charge of 0. You can count out yourself. But these 3 oxygens still have the same problem. They still all have a formal charge of -1, and that's a lot. And also this chlorine, there's 5 around it, right? It's a bit better, but it's still got a formal charge of +2. So this still doesn't look great. Well, let's just keep adding double bonds. What if we add a 3rd double bond? Or a 2nd double bond over here. Again, this fixes this oxygen. It's now 0 as well. But these are still going to be -1, of course. And this chlorine is going to be +1, which isn't too bad. But we still have 3 with non-zero formal charges. So let's look a bit further to see if we can do better. Let's add a 3rd double bond. Let's add a 3rd double bond here. And so now we have 3 oxygens that are all at 0. And this oxygen is going to be at -1 still. But this chlorine, crucially, is at 0 now because it's got 1, 2, 3, 4, 5, 6, 7 electrons, which is equal to the number of valence electrons it normally has. So we've only got 1 atom here that's got a non-zero formal charge, and that seems really good. But just to make sure, let's check the 4 double bond structure, which looks nice and symmetric. Well, here, this oxygen also has a formal charge of 0, and this chlorine has a formal charge of -1. And so we have 2 structures. We have this, and we have this over here. Let's draw a second one. And both of these structures only have 1 atom that has a non-zero formal charge, and it's got a magnitude of 1. So which one do we favor? Here, the chlorine has 0, these all have 0, and the oxygen has -1, and here the chlorine has -1. Well, when just formal charge can't decide the structure for us, we need to look to electronegativity. So in a ClO bond, right, a double bond, single bond, it doesn't matter, the electrons in the bond are always going to be slightly closer to the oxygen because oxygen is more electronegative than chlorine is. And that means that we'd expect a slight positive charge on the chlorine and a slight negative charge on the oxygen. Now I should emphasize this is actually not a very polar bond. The electronegativity difference is pretty small, but it is significant enough to create a small dipole on each side. So which of these is closer to that dipole where the oxygen is negative and the chlorine is positive? Well, it has to be this one, because in this one the oxygen is negative, whereas in this one the chlorine is negative, which is counter to what we expect to see. We expect to see the chlorine be partially positive. And so this one with the 4 double bonds isn't the appropriate structure, and this one with 3 double bonds has to be the appropriate structure. Now notice that we've gone pretty far away from the octet rule. We have 7 bonds around this chlorine, but that's actually fine in this situation, because it's sort of necessary to get an atom that isn't like way too energetic. It's not got way too much formal charge.